And today we will speak about object-oriented programming. So what this is, object-oriented programming is an approach in programming in which properties and behaviors are bundled into individual objects. Like in real world, we have objects that do functions, that do things. For example, we have cars that have features like the color, the model, the engine type, and other features. And then a car can move, can speed up, can brake and stop, or do other functions. Or, for example, in computers, an email has features like recipient list, a subject line, and the body. These are the features, and an email can do behaviors like adding attachments or sending. Or even us, a person. A person has features like name, height, weight, address, and a person can walk, talk, and laugh, and do other things. So the same mentality goes through the design of object-oriented programming. We have objects that both represent features and some functions that can be applied to those properties. So in Python, we have each of these objects are instances of a class. Like again, every person with, for example, they say this height and name is an instance of the human being class in real world. In the same way, we have classes that define the structure or the form of for several objects that would be, all of them would be instances of that class. So in summary, a class provides the form or structure, and then an object is an instance of the class that has two things: features that we call attributes from now on, and functions that we call methods. So when you hear methods, it's actually a function that within an object. So let's start with, I'll do live coding, but this lesson is adapted from a lesson in the lesson repository in the study group. You can access that. I can also put the same thing that we do today. I have changed it a bit. I can also post the in Jupyter Notebook later. But let's start with defining a class. So we define a class. Oh yeah, sure. Which was shift something? Yeah, maybe too much. No. Let's see. Yes. What is the reverse of this? No, it didn't work. Is this fine now? Is this good enough? Okay. So let's define a class. We want to have a class of, so you have a study on, you are recruiting different subjects for each study, and you want to design a class that you fill in the subject information. So we define, the first thing is defining an empty class. So create a class. The way you define a class is say class, have a name for it. I call them subject class because we, as I said, we have a research going on that we're recruiting subjects. And if you want this class to be empty for now, you call pass. This will be your class. And shift enter. Nothing happened, meaning that, okay, this class has been created. Now we want to create our objects. So for example, I have Jane Doe. I give it an ID number. I want to give it an ID number and the date of recruit or date of admission. And then I want to have another subject, for example, John Smith. I'll give it an ID number and I give it an admission date. So let's do that. So the first thing is to define, for example, again, this can be a variable name, any variable name, S1, for example, any object name. But we want to say this is this belongs to the subject class. So S1 equals subject, parentheses open, parentheses closed. Then we define the different attributes that we want this, or properties that we want this object to have. So F name as for first name of this specific subject or this specific object is S1. Their first name is Jane. Then S1 L name for last name is Doe. Then I want to give it an ID, so S1.ID is, let's say, 111. We start from this ID number. And I give another attribute called a date of admission. And I'll give the date, 2019-01-01. Then I define my second object, S2. Again, it belongs to subject class. My S2.FName is John. Sorry. Then again, I want the LName attribute to be Smith. And I want this object to have the ID of 112. And again, this object has date of admission attribute. That I define as 2019. This guy was recruited 9 days later, 709. Now Shift Enter. We have made this class. For example, we can print. We have made these two objects, and we can print, for example, anything that all of the attributes are now accessible. So I can say print me S1 FName and S1 LName. What do you think it will print? Will print Jane Doe, right? We expect it to print Jane Doe. So we said that we can have functions. Let's have this print function inside our object. So we can define functions within the objects. So I define my class again. I redefine my class subject colon, enter. I define a function within it or a method in it. I name it full name. And now I will have a generic name or a generic key for any object within this class. So I call it self. This function will get self and will do print self.fname and self.lname. Now, whether it is S1 or S2, it will print whatever it is. It's not specific to the object, but whatever in this object that is called, in this class that is called, whatever object that is called. So, sorry, what did I do? Oh, I forgot the colon. So class subject, def for define full name, parenthesis self, colon, print this. So this is the function within a class. Now I rerun the cell that I have, that I fill in the subjects in. So I rerun this sub because now again, I redefine the subject. This is now a subject that is, this is now a class that doesn't have any instances yet. So I have to refill these S1 and S2. And now, so I just rerun that cell, that upper cell. Now, if I say my subject S2 or my object S2, if you do complete, tab complete, you will see that I have date of admission, I have FName, I have full name. This is the function, or this is the method. So it's all the attributes and methods are all accessible within each object. So now I call full name, parentheses open, parentheses closed. And what do we expect to see? S2 full name should be John Smith. So, and this is John Smith. Instead of writing print every time, print S1 name, S1 F name, S1 L name, we have a function within the class that does this for us. But again, with the way we did it in the upper cell is not very efficient. It's both it's both boring and it's both and prone to typos. So any typo that you have in any of these lines, for example, S1 can have F name and S2 could have F name without an E if you had a typo, and then you couldn't call back the same attribute for both of them. So it's actually this thing that we did here is not needed. We can do the same thing as we did for the function for attributes, and we can use a constructor to design the attributes within the class. So let's do that instead of writing every time that what all the attributes that we want for an object. So again, I'll copy this class that I made in the upper cell, and now I want to keep the function, but I want to design or construct an attribute. So the way we do this is, again, def for define. We have a key called init. So for that, we have underscore underscore init underscore underscore parentheses. Again, the first thing is that generic key for any object within the class, any object in that class self, comma. Now comes the attributes that we want that object to have. F name, we want it to have F name, L name, ID, and date of admission. Colon, enter. Now we define the attributes, self.fname. So this init gets those variables, fname, lname, and then it assign it to as an attribute to the object self. It's a style norm to call the attributes the same as the variables that you call. It's just these can be anything. These can be any variable that you like. So then self lname is lname. Then assign self.id, assign ID to it. Then for self.date of admission, assign date of admission. Now this full class defines both the attributes of this class, of the objects, of the instances of this class, and a function for them. We shift enter, run this cell, and now instead of writing every time, I can assign S1 to be class subject. Now fill it with the attributes. John Doe, was it John? 111 for the ID, and date of admission 2009-0101. That was a string. So we had 3 string attributes and 1 integer. And then I define S2 as an instance of the subject again, the subject class. This time, oh, sorry, the first one was Jane, actually. So the first object was Jane, the second object was John, and was John Smith. The ID that we wanted to assign to it was 112, and then the date of admission was 9th of January. Now, again, running this class, there's no error. These two, S1 and S2, 2 objects are defined. Let's see if it works. For example, for S1, again, do the tab complete. You have all the features, all the attributes, and let's call full name. Let's see, yeah, Jane Doe is assigned. We can, something very nice about object programming is, object-oriented programming is that we can relate objects to each other. So for example, now that we have subjects, we can literally define relationships between them. For example, for S1, I can define a new attribute called relatives and assign the whole other object to this attribute of S1. So for example, I say S1 relatives. We want to also know if our subjects are relatives. It's a genetic study, for example, is important for us. So S1.relatives is S2. So we know that John is a relative to Jane, and we want to define that. And now, when we run this, if I run now all that object and the attributes and the functions of that or methods of that object is now accessible through S1. You can now see that if I call S1.relatives, so first, let me show you that with the tab complete, you can see that S1 has an attribute relatives. And then if I call relatives, you can see that all the attributes of that other object is accessible within this object. So what do you think we'll have if I call full name? If I call S1.relatives.full name, what would you expect me to see? John Smith, yeah. So this is a very nice way to, well, this is a very simple example, but you will see that how you can work within objects if you have nested data. Now let's work with a total different example. Assume that we are in a bank. We want to define a class called clients, and we want that each instance to have the client's name, the client's balance, and an account level. Let's design the whole class and different objects for this purpose, for this example. So, example of a bank, client database. Well, we want to create the class. Let's call it client class. Again, we start with class. The name that we chose for our client. We can say object and colon. And now we don't go all the way to define individually first. So we go with initializing the attributes, again with the generic keys as self. And we said we want to have two attributes, name and balance. Then we assign it self name to be name and self.balance to be balance plus 100. That there's a default initial balance of 100. Then we want to define account level. We want to assign level of account based on whatever amount is in the balance, is in the account. So if self.balance, this here, the conditional statements come to help. If self.balance is less than 5,000, colon, self.level is basic. This is too small. Else if self.balance was less than 15,000, colon, assign self.level to be string intermediate. Else, the last option, if we have self.level, I mean, if it was more than 15,000, then it would be advanced. Categorizing people based on their money, unfortunately. Well, that's how banks work. Okay, if I run this, hopefully I don't have a typo. You usually have, yes. Again, I forgot colon. Colon is a very important thing. Never forget that. Okay, now we have designed our class. Let's see, let's create our objects. Create 2 instances of this class, i.e. objects. So if you hear instance, if you hear object, these are all. So we want C1, for example, to be of the client class type. And the first will be, this time, John Doe. And he has deposited 5,000. It started with 5 or 500, whatever. And then our client C2 has the name of Jane Defo, and they have 150,000. Very rich. If we run this, okay, we have now 2 objects. Let's see what do we have from them. Yeah, we have balance, we have level, we have name. So let's see. S1 name is John Doe, of course. What a S2 level is advanced, of course, and the balance. So all the attributes are accessible. We can define, again, like before, that we individually defined attributes, we can always add attributes or delete attributes. For example, we can say, I want C1 email, I want to add email to these objects. So I want C1 email to be jdoe@gmail.com, for example. And I want C2 email, now I want to add emails, email attributes is John Doe. No, John was something else. Oops. It was Jane. Jane DD@gmail. They have fun emails. So again, now if you look, we have also email. But for example, let's say you want to delete one of the attributes. To delete an attribute, we call the del. So let's delete Jane's email or client one's email. Now we won't have C1 email. Again, the 3 attributes that we had before. Now, we may want to have attributes that are common between all our objects. So we can assign these to class. So we can have class attribute that is common and will be accessible over without even calling the object. So we can have, for example, for this instance, for this example, we are only working for one branch. So we can have the bank name and the bank location, for example. Then we will define this as an attribute to client class. So client.bank will be, for example, again, a string called TD. And client.location will be toronto.on. So all the customers of this bank, of course, are TD customers. So we don't need to define it for each object. Now, let's work with methods. We have attributes. We have defined it. 3 different attributes. One of the attributes was in conditional statements, depending on the other attributes. And now let's have a method for this class. Let's have, for example, something that when a person updates their bank account, when they withdraw or deposit, it will show on their account. So let's create the methods. Let's create some methods. What? A method to show, withdraw, or update the object upon withdraw or deposit of money. So for that, I copy paste all the class. We don't need to rewrite it. So I just copy paste the class, and now I add my method to it. So a method for deposit, I call it def deposit. Def deposit. Again, I call self, and I need the amount that was deposited. So this gets amount as an input, this method, and changes the balance. So I need to call self-balance, self.balance, and add amount. You know, this plus equal is adding something to the variable and putting it back to the variable. So this means that I will add amount to the balance and put it back to the balance attribute or to the balance variable. And then I want to return, I want this method to return self.balance. So anything that is happening within this object now. And so it's nice because then all your all this method or all this function is applied to each individual object. You don't need to be careful that you, for example, don't add the amount to other people's account. So this is completely individually on the objects or on the individual objects. But again, you will do it in one go every time. So now I want to define a method for withdrawal. So I define def withdraw, parenthesis, self, comma, amount again. We need to get the amount. If now here we can't withdraw if there's not enough money, so we need a conditional statement and say if the amount is more than the balance, give an error. So if amount is bigger than self.balance, comma, raise this error, runtime error, insufficient. I want to say this can be anything. This can be your sentence. I want to say, tell the user that there is insufficient for withdrawal. Else, sorry. Else, colon. Now, if it was enough balance, subtract the amount from balance and put it back in the balance. Self.balance minus sign equal amount and return it. This should be on the level of if. Return self.balance. Again. Yeah. Now we have a class that has some attributes and has 2 methods as well. So let's again run this so that we define John Doe and C1 and C2 clients. Now, if I do the tab complete, did I enter? Wait. Hopefully we will have. Why don't I have the method? So I have this client. Let's run this again. You know what? Let's restart the kernel and clear the outputs. I don't know why C1 doesn't change. Oh, maybe because I had a typo again. But now I define this class, and I put define or create these two objects. Now, so I don't have the. Deposit. No. I guess I should have a typo somewhere. So I'm defining client here. Which yes. No. Let's see if it dropped. If it dropped, it doesn't work. Class client init self name balance is working. I have no idea.
What happens when you stop there?
I only have the three. Yeah, the. Yes. Sorry. Indentation is wrong. Exactly. This should be. This is under. So this is happening under else. Everything else, all the methods. So because of just one indentation wrong, these two methods were under my else. So they were only running if there was not, if it was an advanced level. But it's, yeah, maybe, so let's see. So we should have it for, no, we don't have it for C2. We don't have it for C2. No, I don't think so. Well, let's see now. Let's see if we have it now. We should have it now. Yeah, we have. Probably I had run it. Yeah, already after. So now I have. Let's see. For example, we want to deposit for C1 that had not enough money. We want to deposit C1 to C1 wants to deposit 150,000 again. Now we have 150,000 and 600, and now C1 level has gone up, probably. Right? Still basic. And they started with basic, it doesn't change. it change though? Shouldn't it change their level when we deposit a lot of money? Is it more than the 5? Yeah, it's equal. No. Let's see what is balance. Yeah, the balance is more than this. So I assumed that the level changes automatically, but it seems that it's not. What should we have changed to change it automatically? Interesting.
So you need to be part of.
It's setting the level when you initialize, right?
Yeah, so it's just.
I would have you change.
Sorry?
You only set it when you initialize, right? In the init.
Ah, yes, exactly. Yeah.
The account level definitions also have.
Yeah, if we have this again inside the, for example, deposit, then we will change the levels. Let's do it.
It's only one.
Yeah. So yeah, we should have it after initialization. Before a return. Now, the level is advanced. So the next thing that I want to talk about is our static methods. Static methods are methods that belong to the class, like the attributes that belong to the class, and they don't need an object to be called. So for example, and that is defined again with a keyword, if I may say. I'm not sure if the terminology is right, but we define, so let's do it. Let's have the same class. So define a static class for client. A static method for a client. I copy paste the whole thing, the whole class, and I only add a static method to it. So again, make sure that you're properly indented and define at static method. This tells the program, the interpreter, that this is only, this belongs to the whole class and not the individual objects. So for example, I want to have something funny, make money sound. It's just something random, make money sound. Parentheses open, parentheses closed, colon, print, cha-ching, as if this is the money sound. Again, we run it. Now, when you want to call a static method, you call it by the whole class name. So class dot, when I call client, now client dot, it has an attribute, it has a method called make money sound. And when I call it, when I run it, it will make, well, it will print this sound, cha-ching. The next thing is that static method. So I can, if you see, this is common between the class and objects. So if I call C1 as well, C1 should also have this. I should call C1 again. I should run C1 after I recreated my class with the new static method. I run this, or maybe I should copy paste it. I shouldn't go back up. So copy paste this, creating these two objects and run it. Now my C1 also has this make money sound. So static method is common between class and object. But what if we want to have only class methods? That's when we go there, the same thing. Instead of saying add static method, we call add class method. So I again copy the whole thing just to not confuse you, to delete this. I copy this whole thing again, the definition of the class. And I call here add class method. I want to print the bank location, bank name and location when this is called. So I call this function or method bank location. And this is for my class. And then it only returns a string that has, so now instead of self, we have CLS, again, a generic key for the class. Bank, CLS.bank plus sorry, I forgot that we should have now, we haven't added this because we want to use the class level attributes, we should define them. And that is where we can also define it under the class. I can press enter. Sorry. I don't know why I can't press enter. It's funny. Never mind. I delete the whole thing. We have to call our or define our class attributes. So I said that we want to have a class attribute as CD because here we called it or we defined them after we created the class, but we can also create them within the class. So I say client, class client, let's say object. My attribute is bank. Am I in Vim mode? Why can't I enter? What's wrong with my mode? Chrome? No. It doesn't. Huh. Really strange. Yeah. It doesn't work. Shift enter. I mean, shift enter goes to the others. It runs it. What?
So if you start a cursor at the end of a line above the cell, and drag it down to the next line, just copy all that empty space.
Yep.
Then you can paste quote unquote on each cell.
Can you say it again?
So if you put, let's say you put 2 cells up, if you put your mouse at the end of the cha-ching, then hold down the mouse button and drag it down to the next line, but just one line, not 2. Yeah, and then copy that.
Okay.
I guess you could paste that.
Okay.
It works.
Okay. That's
It's weird.
yeah. I'll do it. Yeah. Good. Okay. That works. Whatever. Whatever works is good. Thanks for the creativity. So we want to call, so we wanted to have bank and location. And so we will have Toronto, Ontario as location. And then we'll copy paste the rest from above, initializing the object and the attributes and the method. We don't want this static method anymore. Oh, wait, I need that space. Okay, I need this. Let me have. Hopefully it works. Now we wanted something. We wanted a class method. So we wanted to have this class method that gives us the bank and location, prints for us bank and location. So we call it bank location, CLS. So it's for the class. And it returns a string that gets cls.bank and adds a space and adds the bank location, cls.location. Now if I call client, do the tab complete, you can see that we have a method, class method called bank location. And if I run it, I will get Toronto, Ontario, TD Toronto, Ontario. The last thing for today, it's at 7, I wanted to also talk about inheritance, and that you can have a child and a parent, meaning that you can have one class that has some attributes and some methods, and then you want to have classes that have all of them have these attributes and methods in common, but they also have their own added attributes or methods. So you don't want to repeat again, copy pasting those in each class, but to have one class within the other. Again, this is a kind of nesting, but in class level. So we can, for example, for this example, we can have a savings class under the client class that has some other features and attributes. So let's see how we do it. So create a child for client class. So I call class. I call this class savings. And this is savings that is within clients. So this savings is in clients or a child of the clients. Now, so one thing that it has is interest rates. Savings accounts usually have interest rates. I should define an interest rate for it, 0.005. And I define a method that says update the balance. And then again, I call generic self, and I call self balance. Add the interest rate to the balance and add it to the balance. Substitute the balance. So self.balance times self.interest rate. and return self.balance. Again, the colon, as always. No. Isn't client defined? Oh, sorry, clients, not client, not clients. So now I want to create an instance for this savings class that has the saving class. So I call C3, for example. Call C3 is savings of a person called Thomas Smith that started with 50. So Thomas Smith has opened a savings account. This account, this object has the same all the different attributes that client has, but it also has savings. It's a special class within class. Now, if I look at C3, it has balance, it has bank location, deposit, interest rate, now level, location, and all the previous attributes. So for example, if I say C3 name, I have Thomas Smith, and whatever interest rate is whatever we gave it. Yeah, so and because we can also do the balance, for example. So if he has started with 50, we expect it to have basic level. So all the attributes of the class is also accessible. One last thing is that we can define a method outside the class definition. For example, we can have just a method to say, hey, check the balance. So I can just define check balance, not inside a class, nothing, but say check balance. Again, self, this is a function. Return self.balance. And if I do client, if I define this as a attribute to the client, check balance, and the method to the client class. So I define it somewhere else. So you can have a function written somewhere else, but you want to define it as a method inside your class. You can just actually assign it to a method inside the class. So assign it to a method called check balance. Now my C3, for example, hopefully also has check balance. And if I do this, it will give me the balance of the person. So it's not that you always have to, again, if you have defined a function somewhere else, you can use it and assign it to your class. That was the whole day. Any questions? Was it useful? Hopefully. You want to turn off?